Here's a vector demo that will show you how simple it is to work with and how you can really take control when you need to. This is a console application, the same kind of sample apps that I used in part 1 of this course. No windowing, no buttons, no event handling, just a place to show some code running. And lots of stuff put out onto the screen using cout. Now I could have done using namespace std at the beginning of this code. I want to deliberately use the namespace, at least for this first demo, to really make it a reminder. Vectors in the std namespace, cout is in the std namespace, and so on. It's an embarrassing thing to forget when you go to write the code yourself. So you can see here that I have declared a vector of integers. Whenever you declare a vector, you have to say what it's a vector of, and then it's strongly typed, and you can't put the wrong sort of thing on it. So I'm going to put a number of simple little numbers that are easy for us to remember onto the vector using this pushback. That puts a new element at the end of the vector, and they're kept in the order that they're added. Then I have a little for loop here that runs through and prints out the contents of the vector. If you haven't seen this before, this is really a super important concept. The concept of an iterator. An iterator is something that knows how to go through a collection. So when you call this method begin of the v vector, it will return you an iterator that's pointing to the beginning of the vector. This method end returns an iterator that's pointing not to the last element in the vector, but past that. Our loop, therefore, goes from the beginning until we are past the end. Now, I'm taking advantage of a wonderful C++11 feature known as auto. Auto is like var in C# and other languages that are strongly typed, where you're giving the compiler the opportunity to say what the type is and then stick to it. You're just not going to press keys on the keyboard in order to say what the type is. So here I said that v was a standard vector of ints. I is an iterator that knows how to iterate through a vector of ints. If I hover over it, you can see it's a standard vector iterator of standard vector of ints, and it goes on and on. There's a number of nested templates. I don't feel like typing that, so I typed auto. I is still very definitely a strongly typed iterator, and it knows how to iterate through this vector from the beginning to the end. So if I were to run, let's just run to here. And I hover over v, you can see that it contains those 4 integers, and you can see them in order. The square bracket 4 is telling you the size. Vectors also know their size, and you can ask it if you wanted to use a more traditional loop, sort of I is 0 to less than some number. You could ask the vector for its size in order to do that. And the iterator will print them out in that order. If we flip over to the output, we can see that's the order that they've been printed out to the screen. 3, 6, 9, 2, same as the order they're sitting in the vector, same as the order we added them into the vector. Now, what if you wanted to show these in a different order? Well, there's another pair of iterators. See here, rbegin and rend. They're called reverse iterators. So rbegin is the beginning when you're doing it in reverse, so it's the so-called last element of the vector, and rend is past the end when you're going in reverse, or I suppose before the beginning. And if we run down to this line and look at the output, sure enough, it comes out in the opposite order. I'm going to stop debugging for a moment because this gives me a good opportunity to show you something about auto. Auto doesn't mean that, oh, it's whatever type you feel like and I don't care. It just means that I'm not pushing the letters. So if we look at I in this for loop, it's a standard reverse iterator of a standard vector of ints. And if I were to change reverse end here to just plain end, you see immediately I get red wigglies. You see reverse end and end are of different types. Reverse end is a reverse iterator, whereas end is an ordinary iterator. So up here, both begin returns a standard iterator, a forward iterator, and so does end, and therefore this is a good expression, and it's all nice. rbegin and rend also return expressions of the same type, but when I mess around with it, the compiler says your types don't match. So it's not a free-for-all. It's still a very much strongly typed behavior. Now, using reverse iterators is very cool. The vector stays in the exact same order. I don't sort it into as added order. We just go through it in a different order. That's a pretty powerful concept, and we come and use iterators again and again with other collections. You don't have to use iterators. This code here just uses a square bracket notation as though it were an array. And of course, that is a zero-based square brackets. So 0, 1, 2, the actual third element. If we run this, you can see that the 0, 1, 2 element of our vector is the number 9. Now you don't just have to make vectors of integers. Those are really easy. Let's make vectors of some object. Here I have a person class that I've used before in the first part of this course. A person has a first name, a last name, and an arbitrary number, and I have some constructors and destructors and some handy get functions to let me get to the name and the number. So I can construct a person and another person, and then using pushback, put them onto a vector. So VP here is a vector of person as opposed to a vector of ints like V was, and we are only allowed to push person objects onto that vector of person. But we go through it in exactly the same way. Now, when I went through the vector of ints to actually get the integer that the iterator was pointing to, I dereferenced the pointer using the star symbol. An iterator isn't a pointer. It's a solid object, but it overrides the dereferencing operator to reach into the vector and give you the item that's at that point in the vector. When the item is a class, we can use this dereferencing operator to say, I'd like to call the member function getName. I could have said star IP, put the whole thing in round brackets, and then dot getName. This is just less typing. So not very surprising that this will run and print out the two names of the two people that I put into the vector. Let's run to the cursor. And sure enough, Kate Gregory, someone else. The two people that I put in the vector in the order that I put them in because I went through with a forward iterator. And again, I could use a reverse iterator. I could use square brackets to access individual elements of the vector. Very simple and easy to use. I want to just point out the copying, and the easiest way to point that out is to turn on some sort of tattletale code that I have waiting in the constructor and destructor for person. So now we'll just run this again and we'll work our way through from here. So we create the vector on the stack. That doesn't print out anything interesting. We create this Kate object on the stack, print something out, and then the someone else prints something out. Now I'm calling pushback and I'm passing Kate by value. That's going to use the copy constructor to copy Kate to a temporary object to give to the vector. I haven't coded that copy constructor in here, which is fine. We'll just get a bit-by-bit copy as we talked about in memory management. That works just fine, but it won't print out a statement. So you can't see that we're making a copy of Kate, but later you'll see that copy get destructed. So you will see destructor methods come through. So even though I didn't write the copy constructor, I get one. So we step over here. Nothing written on the screen. But when I go to push the second person onto the vector, we do get this destructing on the screen. And the reason for that is when I pushed the second person onto the vector, we needed to reallocate as a bigger vector. Copied Kate over to the new bigger vector that had room at the end, and then cleared away the old person object that was in the old vector. Of course, the one on the stack is still here, hasn't gone anywhere. It's the unnamed temporary that was living inside the vector who's gone away. So then I can quickly iterate through our two items in the vector. You see them printed out here. And then the application is going to run through some stuff that I will show you later. We'll just run right down to here. Whole pile of stuff on the screen that we'll discuss later. But now, when I come out of the application, all of these objects are getting cleared away and deleted. When the vector goes out of scope, all of the copies that it held go out of scope for you automatically. Now this is happening at the same moment that Kate and someone else and the other person objects I created on the stack are also going out of scope, so you see a ton of messages here. But it's good to know that because the vector contains solid objects and the vector itself is on the stack and has stack semantics, when it goes away, the objects it contains goes away and there are no leaks. Using standard library collection classes to hold your objects spares you from a lot of the trouble of memory management. So if you learned how to do old school C arrays that you created with new and square bracket and you had to clean them up with delete and square bracket, when you use a vector, you don't need to worry about that at all. The vector goes away, the solid items it holds goes away, done. It's a very powerful construct. Knowing vector, knowing iterators, and knowing how the memory management works in vectors makes understanding all the other collections within the standard library much simpler.